Okay, so let's solve this first one for y. So we can graph this by hand. Let's add 3x to both sides. So y equals 3x plus 4. Y-intercept is 4. The slope is 3, up 3 over 1, or down 3 over 1 the other way. Down 3 over 1 the other way. Down 3 over 1. So there's our line. And this one, if I subtract x, so that would be negative 1/3 y equals negative x minus or plus 1. Let's multiply everything by negative 3. So if I do that, I get y equals 3x minus 3. So negative 3, slope is 3. And pretty soon you can see these two lines don't cross at all. They have the same slope, right? Slope is 3, slope is 3. These are parallel lines. There is no solution. So they don't cross. We're looking for where they cross, and they don't cross. Elimination or substitution. So substitution, this one's nice. We're just going to plug that in there for D. So we get 1/2, instead of D, would be 2 minus 6C. Minus C equals 1. The 1 minus 3C minus C equals 1. So I'm going to subtract 1 from both sides and add the C's together. I get negative 4C equals 0. So C equals 0. We have to solve for D as well. So if I plug in 0, I get D equals 2 minus 6 times 0. D equals 2. So my ordered pair is 0, 2. Always write your answer in this section like an ordered pair when you're solving a system. Elimination, first thing you have to do is get all the x's and y's on the same side in the right order. So this first equation will become 6x minus 4y equals 5. The second equation would be negative 9x plus 6y equals negative 5. Let's see, I'm going to multiply. Let's try to get the same exact opposites here. So I'm going to multiply the top equation by 3, bottom equation by 2. I think that should get rid of the y's. So that becomes 18x minus 12y equals 15. And negative 18x plus 12y equals negative 10. When I add, I get 0 equals 5, which is not true, so there is no solution here. No solution. Graph the system. So this is a vertical line. Sometimes we have some linear problems about those, linear programming problems. Going to graph a quadratic. Okay, so this means everything flips over. So if I start with the 5 points I know and love, 0, 0, 1, 1, 2, 4, negative 1, 1, and negative 2, 4. Multiply all of them by a equals negative 1. So this will be 0, -1, -4, -1. They all become negative, -4. We'll plot those 5 points, 0, 0, 1, 1, 2, -4. That's 1, -1, -1, -1, and -2, -4. This is going to go to the right 3 units and up 2 units. So every point goes to the right 3 and up 2. That's my new vertex. To the right 3 and up 2, right 3 and up 2, to the right 3 and up 2, and to the right 3 and up 2. So I have enough to graph my graph. If you wanted to add the y-intercept, you could plug in 0 and figure out the y-intercept if you wanted, but the 5 points is enough for this one. If they ask about the axis of symmetry, it would be x equals h, which is x equals 3 in this case. Good formula to have written down. Now to complete the square, find the min-max value. Okay, so complete the square, so this can be subtract the 4, so we get y minus 4, move the constant over. We're going to add some to both sides. In this case, half of 8 is 4, 4 squared is 16, so that's 16 on both sides. Get y plus 12 equals, that should be a perfect square. X plus the square root of 16 is 4, and move the constant back over. Y equals x plus 4 squared minus 12. Find the min-max value, so I think the fastest way to do that is this is going to be option 8, 2 times 1, which is -4. To find k, we're just going to plug in everywhere there's an x. We're going to plug in, so we get 16 minus 32 plus 4, so 20 minus 32, 12. So find the min-max. So first of all, this problem opens up there, so it opens up. So the min value is k, which is -12. So how low is the k value? I don't need the h, the minimum maximum value. Didn't ask for the ordered pair, asked for the value. Try to factor trinomials when leading coefficients other than 1. Okay, let's just factor this one. This is just with I'll probably guess and check this one. A 7 and 5 probably work. Let's see. So the bigger number's got the negative. I think that works. Double check it. I'm going to do the AC method. So off to the side for this one, I'm going to do AC. So A times C is -18. But factor that as many different ways as I can. So 1 and 18, 2 and 9, 3 and 6. Which ones add to make -7? I think that works. That might work if 9 is negative. So split up that middle term, right? So it's going to be 3x squared minus 9x plus 2x. So the -9 and 2, and then -6 is still there. Just split up that middle term. Factor by grouping. Take out the GCF, 3x times x minus 3 plus 2 times x minus 3. And so regroup it, and you have your factors, which are 3x plus 2 and x minus 3, because the factors solve by graphing on a calculator. Okay, so get your calculator out, and we're going to type in x squared plus 4x minus 6. And so you can use the trace command, menu 5.1. Where's the 0? You're looking for the x value of that 0. So that's pretty good right there. And so that'll be 1.16. Notice I didn't put the ordered pair. I just want the x value. And x equals -5.16. negative 5. There you go. Now let's solve a quadratic by completing the square. So we're going to try to solve this by completing the square. Let me see something for a second. So this problem was supposed to read 0 equals that. So we're going to complete the square. Move the constant over, so we get 2 equals x squared plus 8x plus blank plus blank. Half of 8 is 4, 4 is 16, so I add 16, I get 18 equals, should be a perfect square, x plus 4 quantity squared. We're going to take the square root of both sides. Don't forget plus or minus. Square root of 18, so if you do 18, that's 18 is 2 and 9, 3 and 3. So we have a pair of 3s with a 2 left over, so this is plus or minus 3 root 2 equals x plus 4. Subtract 4 and we get x equals negative 4 plus or minus 3 root 2. Sorry. So that one had to be one where I just said equals 0 and solve it. Or is it across the x-axis? So know how to solve a quadratic using the quadratic formula. Okay, so this is, you hopefully remember the quadratic formula. Write it down if you don't. X equals opposite of b, which is opposite of 2, over 2 times a, which is 3, square root of 4, which is b squared, minus 4ac. So 4 times a, which is 3, times c, which is negative 1. So if you do that off to the side, that's really 4 minus negative, so plus 3 times 4 is 12, which is 16. So that goes back in underneath there, which square root of 16 is 4. So we get, these by the way cancel. So you get x equals negative 1/3 plus or minus, this is square root of 16, which is 4 over 6, which is negative 1/3 plus or minus 2 over 3, which is two different answers, right? Negative 1/3 plus 2/3 is 1/3. Negative 1/3 minus 2/3 is negative 3/3, which is negative 1. So we get our two answers there. We're going to add, subtract, multiply complex numbers. Okay, so we're going to FOIL this one. We get 2 minus 4i plus 3i minus 6i squared. These go together. So it's going to be, I'm going to put the, well, and what's this really? This is really equal to, this is negative 1, right? So that's really like plus 6. So 2 plus 6 is 8 minus I. This one, up top, when you FOIL that, you get 9 plus 6i plus 6i is plus 12i plus 4i squared, which is really like minus 4. So that's, I would probably write that as 2 separate, but ideally that's 5/13 in the form a plus b, the third form there. And behavior, first term is the biggest here, so this is going to be negative and odd. That's like a lefty John Travolta, that's up, down. Now sketch a graph, so we have our solutions of 2, negative 2, and 0. That's also going to be the y-intercept. The end behavior is going to be x to the third power. So that's down, up. So down over here, but on the right is going to be up. All these are odd, so they're going to go through. So not sure how low they go. The question is how low or how high does it go? So if we plug in 1, I'll know it'll be 1 minus 2 is negative 1 times 1 times 3, which is negative 3. So now I know 1, negative 3. So I know it goes down to about there. Let's plug in negative 1. So I'm trying to plug in at least one point in between each set of solutions there. So this would be negative 1 would be negative 3 for the first parentheses, negative 1 for the second one, and negative 1 plus 2 is 1. So we get positive 3, so it goes up. Oh, that's symmetric. It's pretty nice. Something like that. Pretty good graph of it. Right, polynomial standard form. So polynomials like y equals or f of x. The factors, there's got to be 3 factors. There's 3 solutions. So x minus 1, x minus 4, and x minus 0. If you want to write it that way, you could just write x. I'll follow these two guys together. That'll be x squared minus 4x minus 1x is minus 5x plus 4 times x. Distribute the x to everything. You get x cubed minus 5x squared plus 4x. And that would be one function, polynomial function, that has those solutions. Difference of squares, etc. So, 49 is nice number, 64 is nice number. I think we can factor this. See it? I do. This is going to be 7x and 7x. 64 is 8 and 8 there. One of those plus, one of those minus. You got it. This one, you know the formula for difference of cubes. A would be A, theoretically. B and the formula would be 3 in this case, because 3 cubed is 27. So the factoring would be, I need to actually solve it. Sorry. Okay, so I'll factor it over here. So this would be x minus 3 times x squared plus 3x plus 9. So this solution is x equals 3. That's one of our solutions. I do the quadratic formula. X equals opposite of 3 over 2 times 1 plus or minus b squared should be 9 minus 4 times 1 times 9. So 9 minus 36, which is negative 27, goes inside of there. So we get x equals negative 3 halves I root 27 over 2. Does 27 simplify at all? That'd be like 3 and 9, 3 and 3. So it does simplify a little bit. That's x equals negative 3 halves plus or minus. This is plus or minus, by the way. 3i root 3 over 2. Long division. So let's do some long division here. So 2x plus 1, 2x cubed plus 9x squared plus 14x plus 5. Okay, 2 goes into x cubed. Let's see, x squared times. So x squared goes in that column. So 2x cubed plus x squared. Subtract everything there. So I'm going to distribute that. That's going to be 9x squared minus 1x squared is 8x squared plus 14x. That'd be times 4x there. So plus 4x. So we get 8x squared plus 4x. I'm going to subtract both of those. Distribute the negative. So I get 10x plus 5. Multiply by 5, so plus 5 there. We get 10x plus 5. I like that a lot. I'm going to subtract that, which means distribute the negative. We get 0 as a remainder, which means our answer is right there with a factor, in fact. So when the factor like this, what goes in the box positive 2. Got to get that right. A lot of students were messing that up. So that really, if they gave us a solution, we should put it in the box. 1, 2, negative, or positive 4. And you add, you get 0. Shoo. This is x. This is x squared. List the possible rational zeros here. So factors of 9. So 1 and 9 plus or minus 3 and 3 plus or minus all over factors of 1 and 2. That's the factors of the first term. So we're using this term and this term. So that translates to every possible fraction be everything over 1 is just 1. So plus or minus 1, plus or minus 9 over 1, plus or minus 3 over 1. Those are all integers. And then we have everything over 2. So plus or minus 1/2, plus or minus 9/2, and plus or minus 3/2. So all 12 of those answers there. You want to find all the real zeros of a polynomial. So all the zeros of a polynomial. So this one, I think it's in the calculator section. So let's try to get the real zeros. Let's get the rational ones from the graph. I think this is how we've done this one. So might be able to do it another way, but let's try it this way. So x squared minus 3x squared minus 4. Okay, it looks like it crosses at, ooh, so let's see, factors of, ooh, it doesn't cross at nice numbers, does it? NU5, 1. 1.32, ooh, negative 1.32. I don't love those answers. Those don't seem rational to me. Let me just kind of see something. If I hit plus sign, yeah, those are not rational. So there are no rational zeros for this one. We could try to factor it. This would be kind of weird factoring here. So if you've tried to factor it, you could factor this with, like, instead of x and x like you would normally do, it'd be x squared and x squared. And 4 and 1 look like it would work. The bigger number is negative, so minus 4 plus 1. Ah, that works. So you might be able to factor this. First term factors some more, so that's x plus 2, x minus 2. Maybe I didn't type in the right thing. So times x squared plus 1. Let me double check what I typed in. I have a feeling I typed it in wrong. This is why it didn't work. So that would be a way to solve it. I don't think we've done much of that. I think we should probably, let me see if I typed this in right. I'm still not sure if I typed it in right. X squared, x to the fourth. Boy, I really did not type this in right. Okay, now we're looking good. Okay, so if you see, like, that's a 0. Oops, that's a 0. So we do have solutions at 2 and negative 2. So you can forget this. You don't need that. I don't think we learned how to do that. We have learned how to do this. So you do 2 in the boxes, take one of them out at a time. Put the coefficients. Don't forget zeros for the ones that are missing. So there's no x cubed, so I'm going to put 0 there. Negative 3, there's no x, so I'm going to put 0 and negative 4. I know the remainder should be 0 here. So 1, this would be 2, 4, 1, 2, 2, 4. Remainder 0. That's beautiful. Take the second solution out, which was a negative 2. Okay. This would be 1, negative 2, 0, 0, 1, negative 2, 0. Okay. Remainder, this is constant, this is x squared. So this is end up being x squared plus 1. We know two of our solutions already, 2 and negative 2. To find our third, we're going to set that equal to 0. Subtract 1, x squared equals negative 1. Square root both sides, don't forget, plus or minus. You get x equals plus or minus I. So those are two imaginary solutions. So those are your 4 solutions. That's a little bit better. We didn't really learn how to factor that. That's kind of cool though to do. We haven't learned how to do that yet. Okay, finally, we're to Pascal's triangles. This is like the last problem just about here. So Pascal's triangle, to expand a polynomial. So let's write Pascal's triangle off to the side a little bit here. So this is 1, 1, 1, 1, 2, 1. Remember, you're adding those two to get the next one. So 1, 1 plus 2 is 3, 1 plus 2 is 3, 1. Let's see, I need the fourth power, so I need the fifth row. So 1, 2, 3, 4. I need the next row. 1, 4, 6. So I'm taking these coefficients. I'm going to kind of write them off to the side here. So 1, 4, 6, 4, 1. First one to the highest power, so this would be 2x to the fourth, 2x to the third, 2x to the second, 2x, it's just constant there. Negative 1 to the highest power over here, so negative 4th, negative 1 to the third, negative 1 to the second, negative 1, it's constant. Some of these might change signs, so I have a negative in there. So 2 to the fourth is 16, so this is 16x to the fourth. Definitely going to be minus because that one's to the first power. 2 to the third is 8. 8 times 4 is 32. Definitely going to be plus because this is going to be positive 1. 2 squared is 4. 4 times 6 is 24. Definitely going to be negative because this is to an odd power. Negative to an odd power. 2 times 4 is 8, so 8x. And this is going to be positive because negative to an even power, so there's just 1. And we have it. We've expanded that. It's pretty solid. So we'll get to, I think we're going to do this during a synchronous class. So this week I'll put a message, an announcement about that. Okay, that's great. That's the end of our review of Part B here.